Welcome to LinuxConfig.org. In this tutorial, we'll explore ZFS deduplication, a feature that automatically eliminates duplicate data to save disk space. We'll compare storage usage with and without Dedup, and demonstrate how it allows you to store far more data than your physical capacity would normally allow. Let's get started. First, let's check our current ZFS pool status. We have a 9.5 gigabyte pool with minimal data currently stored. The Dedup ratio shows 1.00x, meaning no deduplication is active yet. We also have our LinuxConfig dataset ready for testing. Let's open another terminal tab to create our test data. First, we confirm that deduplication is currently off on our dataset. Now we'll generate a 10 megabyte file with random data and copy it 3 times to our dataset. Listing the files shows 3 copies, each 10 megabytes, totaling 30 megabytes. The ZFS list command confirms 30 megabytes used. And checking the pool, we see 30 megabytes allocated with a Dedup ratio of 1x. This is our baseline. Without Dedup, 3 identical files consume 30 megabytes of physical storage. Let's open a new tab so we can compare with our previous results. First, we remove the test files and confirm the dataset is back to its original size. Now we enable deduplication on our dataset and verify it's turned on. With Dedup active, we copy the same 10 megabyte file 3 times again. The file listing looks identical. 3 files at 10 megabytes each, totaling 30 megabytes. But here's the difference. ZFS list shows 30 megabytes used, which is the logical size. However, zpool list reveals the truth, only 10 megabytes allocated with a 3x Dedup ratio. This means ZFS recognized all 3 files contain identical data and stored it only once, saving 20 megabytes of physical space. Let's open a new tab for the stress test. We'll use a loop to copy our 10 megabyte file 2,000 times. This creates 20 gigabytes of logical data, more than double our available pool space. The du command confirms 20 gigabytes of data in our dataset, and df shows the file system reports 20 gigabytes used with 69% capacity. But here's the real proof. Zpool list shows only 26 megabytes physically allocated with an incredible 2000x Dedup ratio. We've stored 20 gigabytes of data using just 26 megabytes of disk space. This demonstrates the true power of deduplication, storing far more data than your physical capacity would normally allow. Now let's compare our 2 tests. With Dedup enabled, we stored 20 gigabytes using only 26 megabytes, a 2000x ratio. Without Dedup, the same 3 files consume 30 megabytes with a 1x ratio. The difference is clear. Dedup can dramatically reduce storage when you have identical data. However, before you jump into using Dedup, consider the requirements. Dedup needs significant RAM, roughly 2 gigabytes per terabyte of storage. If the Dedup table doesn't fit in memory, performance degrades severely. Dedup works best for VM images, backup repositories, or environments with truly identical files. For general use cases like web hosting, compression is usually a better choice. Finally, let's see what happens when we modify one file. We overwrite copy 999 with new random data. After running sync to flush the changes, we check the pool. The Dedup ratio dropped from 2000x to 1000x. This makes sense. We now have 2 unique data blocks instead of 1. 2,000 files divided by 2 unique blocks equals 1,000x. This shows how dedup ratio changes dynamically as your data changes. To summarize, ZFS deduplication is powerful for environments with highly redundant data like VM images or backups, but for general use, consider compression instead. It's lighter on RAM and works well for most workloads. Subscribe for more Linux tutorials, and thanks for watching.